All right, so today we continue with the elasticity of demand and supply. The last time we looked at what demand is, what supply is. Those are the market forces that determine price in any competitive market. Okay, so today we look at demand, the elasticities of demand and supply. Now, these are the objectives for today's lesson. Before we finish, we should be able to define what price elasticity of demand is and explain the factors that actually affect the elasticity of demand, and then we also learn how to calculate or measure elasticity of demand. They also define the price elasticity of supply, then look at the factors that affect elasticity of supply and also learn how to calculate it. Then we look at cross elasticity of demand. The elasticity of demand, we have home price elasticity, cross price elasticity, and income elasticity of demand. So after we are done with the home price elasticity of demand and supply, we look at cross elasticity of demand. We also look at some of the factors that affect that. Okay. So those are the objectives. Let's begin with the price elasticity of demand. So basically, we use elasticity to measure the degree of responsiveness of demand to changes in either the price of the commodity, price of a related commodity, or the income of the consumer. That is the use of elasticity. We want to talk about elasticity of demand, but specifically talking about the price, the own price elasticity of demand, then we want to look at how quantity demanded of a good changes in response to a price change. So when the price of the commodity changes, how will demand respond? Okay, so it's a measure of the extent to which the quantity demanded of a good changes whenever the price of the good changes. So this price, we are talking about the price of the good itself, the good in question, not any. Okay, so that is what price elasticity of demand is. Now, for us to actually get price elasticity, we compare the percentage change in quantity demanded to the percentage change in price. So we compare the two, then we'll know whether the demand for the good is elastic or if it is inelastic, and the explanations for that. So before we can find elasticity of demand, we need the percentage changes in quantity and that of price. Okay. So let's look at how to calculate the percentage change in price. Then we'll look at how to calculate the percentage change in quantity demanded. Now, basically, if you want to find the percentage change in something, okay, the mathematical formula is the new value of the variable minus the initial value divided by the initial value times 100%. Okay, so talking about percentage change in price, then we are looking at the new price, okay, minus the initial price divided by the initial price times 100%. So the percentage you get here will be the percentage change in price. So let's take this example. Starbucks raises the price of a latte from $3 to $5 a cup. What is the percentage change in price here? Okay, so here there was an increase in price from $3 to $5 a cup. So the new price is 5 and the initial price is $3. So we just insert it here, then we calculate the percentage change in price. So our $5 minus $3 divided by $3 times 100%. So by doing this, we get 66.67%. So this is the percentage change in price here. Okay. Now let's look at this. This is an increase in price from 3 to 5. What if price falls from $5 to $3? What is going to be the percentage change in price here? Now remember, it's new price, which is now the 3, minus initial price, which is now 5, divided by initial price, which is 5. So we have 3 minus 5 over 5 times 100%, which is minus 40%. You see that initially the other one was minus, it was supposed to be, this one was 66.67 positive because of an increase in price, okay? And then if there's a fall in price, we get what? A negative percentage. But what I want us to look at is that if you look at the two changes, they all have an interval of $2. An increase in price by $2, a decrease in price by $2, but then the percentage changes are not the same. Are we together? Frank.
Yes.
So you see that the same price change, $2 over the interval, $3 and then $5. One was just an increase, and the other was a fall. But then we are getting different percentage changes. Okay, so the value of the percentage change here is going to depend on whether the change is an increase or is a decrease. Is it a rise in price or a fall in price, which is not ideal. We need to find a way to actually get a single percentage change, which is independent of the direction of change. It doesn't matter if the change is an increase or is a decrease. So we have to get something like that. So for us to get an ideal measurement of the percentage change, instead of dividing it by the initial price, we divide it by the average of the initial price and the new price. Okay, we divide it by the average. Let's look at what we are talking about. This formula, we call it the midpoint method. Okay, the midpoint. So we will still do new minus initial divided by, instead of initial, we use the average of the new and then the initial. That's why. So we take the midpoint of the two prices or quantities, and then we divide it by 2. So the ideal percentage change formula will be new price minus initial price divided by the sum of the new price and the initial price divided by 2. So the denominator is the average of the two prices times 100%. So when we use this formula, it doesn't matter if the change in price is an increase or is a decrease. We'll still get the same percentage change. Okay. So let's look at that. Now, with the rise in price, we have $5 minus $3 divided by, we add the two prices, then we divide it by 2 times 100. So here the numerator is going to be what? It's going to be 2, right? When we add $5 and $3, we have $8 divided by 2. That would be 4. So we have 2 divided by 4 times 100. 2 over 4 is half. Half times 100 is 50. So here the percentage change will be 50%. Is that okay?
Yeah.
Then, assuming it was rather the fall in price, then we'll have 3 minus 5. But then the denominator will still be 4. So we'll have minus 50%, indicating that there was a fall in price. But then we still get the same percentage. It doesn't matter if it's an increase or it's a decrease. All right. Any question?
No.
Okay, so that is percentage change in price. We said to find elasticity, on price elasticity, we compare percentage change in price and then percentage change in quantity. So we've looked at percentage change in price. Let's look at that of quantity. So now we'll be using the midpoint method for both price and quantity, changes in price and quantity, so that we'll get the ideal percentage change. Now, assuming that after the increase in price by Starbucks, we know that quantity demanded of 4, right? When we increase price,
Yes.
we demanded 4. So if you want to find the percentage change in quantity, then the formula will be new quantity minus initial quantity. Then we add the new and the old, we divide it by 2 times 100%. Okay, the value that you get will be the percentage change. So assuming that after the increase in price of a latte, the quantity demanded fell from 15 to 5 units, 15 to 5. So how do we get a percentage change in quantity? New price, which is new quantity, which is 5, minus initial quantity of 15, divided by, we add the 2 quantities, we divide it by 2. So 5 minus 15 will give us minus 10. 5 plus 15 is 20, divided by 2 will be 10. So minus 10 over 10 will be minus 1 times 100, giving us what? Minus 100%. So the increase in the percentage change in quantity was 50%, and then the percentage change in price was 50%, and the percentage change in quantity is minus 100%. Now, we need to understand that definitely one of the percentage changes will be minus because of the inverse relationship between price and quantity. If price goes up, quantity will fall, and vice versa. Okay, so definitely the on price elasticity will always be negative You divide either a positive number by a negative one or vice versa. So definitely the resulting figure is going to be minus, okay, because price and quantity always change in opposite directions. But then we just ignore the negative sign. So we'll just use the absolute value. I hope you are following.
Yeah, sure.
So we just ignore the sign for price elasticity and then we'll use the absolute value. Okay. So we'll come to how to calculate it. We'll see the value, then we'll interpret it as well. Now let's look at the difference between elastic demand and then inelastic demand. Now, generally, if demand is elastic, it means that consumers are more responsive. They are very sensitive to changes in price. When price changes, you see their sensitivity. But then as demand is becoming more inelastic, it means they are less sensitive, less responsive. So when price changes, they don't actually change quantity much. But if demand is more elastic, they do change the quantity considerably whenever there is a change in price. But then demand is said to be elastic if the percentage change in the quantity demanded is more than the percentage change in price. You remember we said we are comparing percentage change in price and quantity. So if you have, for example, the one that we saw for the latte, when the percentage change in quantity was 100%, and then the percentage change in price was 50%. So you see that the percentage change in quantity was more than the percentage change in price. So demand for the latte will be elastic. That is what we mean by elastic demand. And then the vice versa is for inelastic. For inelastic, it means that, we'll go back to the unit elastic. For inelastic, it means that the percentage change in the price will rather be more than the percentage change in quantity. In other words, the percentage change in quantity will be less than the percentage change in price. That's where we have inelastic. So consumers are not very responsive. And then for unit elastic, that is where the percentages are the same. So if price is changing by 20%, quantity is also changing by 20%. That is unit elastic demand. Okay. So and then we have perfectly elastic. For perfectly elastic, consumers are very responsive. Okay, graphically, their price can be the same, but then consumers will demand different quantities of the good. So here, what happens is that it's possible price, the change in price is almost 0%. It's almost like there's no change in price. Yet you see a very large percentage change in quantity demanded. So price doesn't change much. The percentage change in price is almost 0. Yet we see a very large percentage change in quantity demanded. That is what we call perfectly elastic. And the last one is perfectly inelastic, where quantity doesn't change at all, even if price changes. That is the case for the necessities, like salt, the example I've been using, salt. It doesn't matter the change in price. You can't say that now salt is expensive, so when you are cooking, you won't put any salt in it. No, it doesn't work like that. Okay, so these are the 5 types of price elasticity that we have. All right, so these are the 5 types of price elasticities that we have. Any question?
No.
Okay, let's look at the graphical representations. All right, this is the graph for a perfectly elastic demand. So you see that even if price is fixed at this point, okay, I mean, we can demand different quantities of this good. If you look at this, demand can be here. It can go to 100 at the same price. It can even come to 110 at the same price. You see that there's almost like a 0 change in price, yet the quantity that the individuals are buying varies. Okay, so at the same price, we tend to buy more. Now, one thing about this one is that if the producer tries to increase price by a very small margin, it's possible no one will buy the good at all. Okay, no one is going to buy the good at all. So this is what a perfectly elastic demand curve looks like. And then we look at an elastic demand. Okay, an elastic demand. So here initially price was 95. Quantity demanded was 110. Now, assuming price increases to 95, from 95 to 105, so we'll have a 10% increase in price. Look at the increase in quantity, the decrease in quantity from 110 to 90, that is 20%. So if you compare the percentage change in quantity to the percentage change in price, see that that of the quantity is higher than that of price, and that is what we said for elastic demand. So when demand is elastic, it means that the percentage change in price in quantity will be more than the percentage change in what? In the price. Okay, 20% is greater than 10%. So this is what the elastic demand curve looks like. Okay. Then let's look at the unit elastic. Unit elastic, the price increase from 95 to 105. So percentage change in price is 10%. Quantity increase from 95 to 105. A decrease from 105 to 95. So this one too, the percentage change is 10%. So 10% over 10% is giving us what? Is giving us 1. So unit elastic. The percentage change in quantity is exactly the same as the percentage change in price. Okay, as the percentage change in price. Then let's look at inelastic demand. So for this one, the percentage change in quantity should be less than the percentage change in price. So the percentage change in price here, 90 to 110 is 20%. Then the percentage change in quantity from 105 to 95 is 10%. So you see that the percentage change in price is greater than that of the quantity. Here, the curve is steeper. If you compare this to the elastic one, the inelastic curve is steeper than that of the elastic curve. Okay. Then the last one is the perfectly inelastic. Like the case of salt, sugar, water, those kind of necessities. It doesn't matter the price level. We will still demand the same quantity. When price was 95, we'll buy 100 units. If price goes to 100, we'll still buy 100 units. If it goes to 105, we'll still buy 100. So it doesn't matter. It doesn't matter the change in price. The quantity that we buy will still remain unchanged. And so these are the graphical representations of the 5 types of home price elasticity. Okay. Now, what are the factors that affect the elasticity of demand? What will make the demand for a good more elastic or more inelastic? Now, we'll look at, we divide it into two. We have the availability of substitutes, okay? And then the proportion of the consumer's income that he spends on the good. Okay, so what we have to understand is that if a good has substitutes, it tends to be more elastic. You see, elasticity, the demand for a good being elastic just means that consumers are sensitive to changes in price. So if the good has a substitute, remember for substitutes, they serve the same purpose. So it's either I buy good A or I buy good B. So if there's a change in price of good A, I'll be more sensitive because assuming there's an increase in price of good A, I'll just stop buying A and I'll go and buy B, which means that the fall in demand as a result of an increase in price for good A will be very large. Making the demand for the good more elastic. What about if the good has no substitute? If the good has no substitute, then it doesn't matter. It doesn't matter whether there's a change in price or not. We still have to buy the good. We need the good, and we can't substitute it for any other good. So goods with substitutes tend to be more elastic. If you can easily find a substitute, the demand for that good tends to be more elastic. But then if you don't have any substitute, then the demand for that good will be inelastic. You'll be less sensitive. Even if there's a change in price, that consumers will change demand much. Are we together?
Yeah.
Okay. And then for the availability of substitutes, how we can actually get substitutes for a good depends on these factors. Number one, the good being a luxury or being a necessity. Remember, necessities are goods that we cannot do without. But luxuries, we can do without them. Okay? We can do without them. So for necessities, they have no substitutes. Even if they do have, they are very poor. They have just poor substitutes. So if you take something like food, food in general, put everything under the basket of food, anything that we eat. Even if there's a change in price of food, are we going to go hungry? No, we still have to
No.
buy them. So it will be more inelastic. We won't really respond to changes in price. But for luxuries, we don't really need them. We are just we just want to enjoy life. That's why we are buying those luxuries. So if there's a change in price, we just stop buying those ones. Assuming there's an increase in price, they become so expensive. Why bother? Because you can live without them. So they have more substitutes. So their demand tends to be more elastic. So that is one. And then the narrowness of definition. When you are defining a good, the definition can be wide, it can be narrow. Okay, it can be broad. When you broadly define a good, like the example we gave here, food, the definition for food is very broad. There are a lot of categories under food. We've grouped everything together. It is very broad. If it's broad like that, you cannot find a substitute. Are we together? You say food, beverages, main dishes, fruits, vegetables, everything is under food. Where do you find a substitute? You can't. You can't find any substitute. So it becomes inelastic. But if the good is defined narrowly, okay, we give a narrow definition of whatever good we are talking about. For example, we talk about oatmeal. It's very narrow. We just know it is just oatmeal. And oatmeal has a lot of substitutes. We can take tea. We can take coffee. We can take cocoa. Are we together? So,
Yes.
if you narrowly define a good, you can easily find a substitute for that good. But then if you define it broadly, there is no way you can find a substitute. So you just have to be there. For example, if we talk about housing is something broad. All the types of housing will come under, all the types of apartments will come under it, single rooms, story buildings, compound houses, and all that. So there's no good substitute for housing. But then we talk about single room apartment. I mean, you can go for a chamber and a hall. You can go for a 4-bedroom. I mean, I hope you are getting it. So, yes, it depends on whether you find a substitute or not. Depends on how we define the good, okay? And also the time that the change in price and then the consumer's decision. How long? If a price changes for a very long time, we can adjust. We can adjust our decisions easily. Let me give you a typical example. You are very hungry. You are going to a food joint, and you've been going there always. The price of the food is $10 per pack. So you always go there with your $10. You were hungry, you rushed there, you got there, and they said the good is 15. It's $15. Now just think about it. You are very hungry. How do you change your decision then? Assuming there's no other food, you cannot respond to the change in price. You just have to buy the food like that. Am I lying?
No.
You see, you just have to buy it like that, which means you were not responsive. So your demand there will be inelastic. But what if you'll be going to buy the food next week, Monday, and today you heard that the pack is now 15 cedis? You have a longer period of time to decide whether you still go there or you check a different joint. So if you don't go there again, you see that you are being more responsive to the change in price, and you being responsive depending on the time that the price changed and the time that you wanted to buy the goods. So time too is a very great factor when it comes to measuring elasticity. Okay, so if the time span is very low, you become more inelastic. If the time is long, demand becomes elastic. Are we together?
Yeah.
Very good. All right. So, and the second one was the proportion of income spent. Now, let's take two individuals. Okay, let me use this illustration. We have individual A. Okay, individual A is here. Individual A has, let's say, $1,000. Okay, $1,000. And then let's look at this, our individual B. Individual B is very rich. Okay, he has $10,000. $10,000. Okay. Now they are all buying a particular good that costs $500. Okay, that costs what? $500. So now, if you look at this guy is using 50% of his money to buy the good, right? He's taking 500
Yes.
out of the 1,000. This guy is using only 5%. Okay, he's using only 5%. Now, assuming there's an increase in the price of the good to say $800 now. Now, looking at these two people, this guy will be more responsive because he is using a greater percentage of his income to buy this good. So if you have to increase the good to 800 and he still buys it, he's now using 80%, almost the total of his money. He's using almost everything. But this guy will only be using 8%. So this guy will be more responsive. This guy, he might not even change the quantity that he buys. But because this guy is using a higher proportion of his income to buy the good, he becomes more responsive. And the more responsive you are, the more elastic your demand. This guy is using only 8%. It's not even up to 10%. So, I mean, what can this thing do to his money? So, if you are using a greater proportion of your income to buy a particular good, you become more sensitive to changes in price. So, you tend to be, your demand tends to be more elastic. But if the proportion of income that you are using is very small, you tend to be more, the demand tends to be more inelastic. You are not very sensitive to the change in price. Are we together?
Yes.
So that is the explanation for the proportion of income that we spend on the goods too. Okay. All right. How do we compute price elasticity of demand mathematically? Price elasticity of demand is percentage change in quantity demanded over percentage change in price. Okay, so we find the percentage change in quantity, we divide it by the percentage change in price. Now, if the value that you find, now we are using the absolute value, remember, we are ignoring the negative sign. If the value is greater than 1, maybe 1.2, 1.8, 2, 5, we are talking about an elastic demand. So here it means that the numerator is greater than the denominator. So percentage change in quantity will be more than percentage change in price, which makes demand elastic. If it's exactly equal to 1, demand is unit elastic. Okay, unit elastic. It means that percentage change in quantity will be the same as percentage change in price. Now, mathematically, a ratio can be 1 if and only if the numerator is the same as the denominator. Are we together? So the percentage change in quantity should be exactly the same as the percentage change in price before we can get 1. So that is unit elastic. If the value is less than 1, we are talking about inelastic demand. So the percentage change in price, the denominator is greater than the percentage change in quantity, which is the numerator. Okay, so that is it. Let's look at an example. Now, initially, this was the price, okay, at the price of $3. Remember the price for the latte. For $3, quantity was 15. Now, price has increased to $5. What is the quantity? 5 units. So we want to calculate the price elasticity here. Now, for the percentage change in price, remember we had 50%, right? 50%.
Yeah.
Good. And then that of the quantity, we had what? We had 100%. So for us to find the price elasticity, we divide the percentage change in quantity by the percentage change in price. So 100% divided by 50%, that will give us what? 2. Is that okay? It gives us what? 2.
Yes.
Good. So 2 means that what? The demand for Starbucks latte is what? Is elastic. 100% over 50% is 2. 2 is greater than 1, right? So the demand for the latte is what? Elastic. What does it mean? It means that, yes, demand is elastic, which implies that the latte has substitutes. It has substitutes. And it's possible that the proportion of the buyer's income that he spends on it is large. Here, I think there's an issue here. Okay, before the good will be elastic, then the proportion of the buyer's income should be large. Okay, when you are using a larger proportion of your income, that is where demand tends to be elastic. Are we together?
Yes, we are.
So that is it. Now, another implication is that if Starbucks tries to raise the price, now revenue per cup will go up because your revenue is price times quantity. So if you increase your price, your revenue will go up, but you will lose customers because the demand for your good is elastic. Whenever you increase price, the percentage change in quantity demanded will always be more than the percentage change in price. So that is one implication of the good being what? Elastic. But then if you try to lower your price a bit, you gain more customers because they will stop buying maybe something from McDonald's and then they'll come and buy from you. Are we together?
Yes.
And knowing when you own a business and you're able to calculate the elasticity of the demand for your good, it helps you to know whether you have to increase price or not. If the demand for your good is elastic, for you to gain more, you lower your price so that people stop buying from your competitors. They'll come and buy from you. Okay, so those are some of the implications of the elasticity. Now, let's look at elasticity along a linear demand curve. Now, whenever you have a linear curve, the slope of that curve is constant. It doesn't change. The change in y over change in x is constant. But then elasticity isn't like that. Though we have a linear demand curve, elasticity reduces as we move down the demand curve. It's not the same as the slope. The slope is constant, but then the elasticity changes. Now, if you take the linear demand curve, the normal demand curve that we know, at the middle of the demand curve, elasticity is unitary. Demand is unit elastic. So right at the middle, percentage change in price will be exactly the same as what? Percentage change in quantity. Then any point above the midpoint, demand is elastic. And then any point below the midpoint of the demand curve, demand is inelastic. Okay, so it is not constant throughout. It depends on where we stand on the demand curve. In the middle unit, above the middle, elastic, below the middle, we have inelastic demand. Okay, so let's look at what we are talking about. So this at this point here, demand elasticity of the demand is 2. It's greater than 1, so we have elastic demand. At exactly the midpoint, demand is what? It's unitary elastic. So the coefficient is 1, and then a point below the midpoint, you see that the elasticity is 0.5. That is inelastic demand. So it is not constant. It reduces as we move down the linear demand curve. Okay. All right. What is the relationship between total revenue and price elasticity of demand? Total revenue and price elasticity. So we need to know what total revenue is. Now, to the consumer, total revenue is the total expenditure that you make on goods and services. Okay, the amount of money that the consumer spends on buying goods and services. But then to the seller or the producer, the total revenue is the amount of money that he receives from selling units of his commodity. So after you have sold whatever quantity you want to sell, the money you get in return is what we call total revenue. Mathematically, total revenue is equal to price of the good times the quantity that you will sell. Price times what? Times quantity. Okay, price times quantity. That is total revenue. Okay. Now, we have something called the total revenue test, where we are able to have a fair idea the elasticity of demand for the good just by looking at how total revenue changes whenever there's a change in price. So when the price of the good changes, will total revenue go up? Will it come down? When it goes up, we'll be able to know the type of elasticity we are talking about. When it comes down to, we're able to know the type of elasticity we are talking about. So that's what we call the total revenue test. Let's look at that. Now, we know that if demand is elastic, what it means is that whenever price increases, the fall in quantity demanded will be larger in terms of percentages. Are we together? So the percentage change in quantity will be greater than percentage change in price. So if there's a percentage rise in price, then the decrease in the percentage decrease in quantity demanded will be larger. Okay. Now, if this is the case, total revenue will fall. Why are we saying this? We are saying that total revenue is equal to price times what? Times quantity. Now, you've increased price by, say, 20%. So now price is 0.2 or 20% P times. Remember, if price goes up, quantity will fall. So if the quantity is falling by 50%, so 50% times the initial kill, price is going up by 20, quantity is falling by 50. So PQ will fall. Are we together?
Yes.
So whenever demand is elastic, because the percentage change in quantity will be larger than the percentage change in price, if you increase price, your total revenue will fall. Okay, so if you're a businessman and you are aware of this, you know that your demand is elastic. Don't increase price at all. If you want to rather gain more, you rather reduce price, because if you reduce price by 20%, quantity demanded will increase by 50%, and that will increase your total revenue. Are we together?
Yes, we are.
So that is one side. What if demand is inelastic? It means that the percentage rise in price will be what? Will be bigger. Okay, will be bigger than that of the percentage decrease in quantity demanded. So if you increase price by 20%, quantity demanded will fall by, let's say, 10%. So your total revenue will do what? Will go up. So if you are selling a particular good or service and you know the demand for the good is inelastic, if you want to get more revenue, increase price. Because if you increase price, the quantity demanded will fall by a very small margin. Your total revenue will go up. So if you are selling salt, don't be afraid when you increase the price, because definitely people will come and buy. Your total revenue will go up. If you are selling sugar, no matter what, you will buy it. Are we together? So
Yes.
that is the total revenue test that we are talking about. Now, if price and total revenue change in the opposite direction, demand is elastic. So if you increase price and total revenue falls, demand is what? Is